Assalamualaikum. We are from Group 6. We present our group project for Statistics of Civil Engineering subject. Our topic is about study of traffic. Let me begin our group presentation. My name is Muhammad Arash bin Arifin with metric number PF200-105. Our group was conducted a study to determine the traffic speed along 1 km road at Jalan Keluang in front of RTD Enforcement Station, Sri Gading during weekend and weekday. The data that obtained will be analyzed by using the method that already learned.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuratasha binti Abdul Ghaffar with matrix number DF200168 and I will present about the methodology. First is work progress. We identify the variables at first, which is the traffic speed for 2 days, weekend and weekday. And then we collect data, which we use Google Form. And then we present the data, which is the outcome of collected data. And then for data calculation, we calculate the data using the descriptive statistic and inferential statistic. And then the data analysis, we do the discussion and conclusion. For survey respondent, the individuals who answer questions for a survey conducted by the reviewer, and the data results from respondents will be collected and analyzed for achieve the objectives of the project. And this survey is required a total of 80 respondents, which is 40 for the weekend and another 40 for the weekdays. And it is open to people that drive or ride at the Jalan Keluang in front of RTD Enforcement Station Sri Gading. And this is surveyed on the traffic speed on the Next is survey instrument. This field survey instrument uses a questionnaire form through a Google Forms application to collect the data. And the Google Forms, there are two questionnaires which which were on the weekday and weekend, and the questions consist of gender, age, common speed respondents drive or ride at the day during evening, and if they choose above the range that's stated, they need to write the specific value. Next is data collection. The data recorded will be used to calculate descriptive statistics and inferential statistics, and the data that collected from the Google Form will be put in the tables below. Next is descriptive statistics. It is the activity of collecting, classifying, presenting, and describing quantitative data. And the table shows the formulas that we use for descriptive statistics of mean, quartile, variance, medians, percentile, mode, interquartile range, and standard deviation. And for inferential statistics, it is part dealing with technique and method of interpretations of the results obtained from the descriptive statistics. For this project, we use F-test for 2 variants and Z-test for 2 independent samples of traffic study on weekend and weekday. And before start calculate the both tests, we need to testing hypothesis using 5-step procedure. The procedure 1 is state the null hypothesis and alternative hypothesis, and then we select a level of significance alpha, and then we identify the test statistics, and then we formulate a decision rules, and lastly we make a decision. For Z statistics, which is Z-test, the sample mean distributions follow the normal distributions if n is greater or equal to 30. The distributions of the differences will likewise be normal, which is Z distributions, using the formula stated. X bar X refer to the mean of the first sample X, and X bar Y refer to the mean of first sample Y, and Sx squared is the variance of the first sample X, and Sy squared is the variance of second sample Y, and N is the size of first sample X, and M is size of second sample Y. And for F statistics, which is F-test, is the distributions used to test the hypothesis that the variance of normal populations equal to the variance of another normal populations, using the formula F equals to S1 square, which is the variance of the first sample, divided by S2 square, which is the variance of second sample.
Hello, Assalamualaikum. My name is Muhammad Fahmi bin Mazur, metric number DF20093. Next, I will present about the data presentation. So, for the first is steam and leaf diagram. A steam and leaf diagram is a method for presenting quantitative data in a graphical format to assist in visualizing the shape of a distribution. So, the steam in the first digit, which is a yellow color, and green color will become the leaf. So, we need to construct the table like you can see at below, a steam and leaf diagram, which is the yellow number. It will become the steam. So the first step, we need to arrange the data in order of magnitude and then place the steam in order, which is the yellow color, vertical from smallest to the largest. As you can see, the arrow shows from the top to the bottom. And then place the leaf in order, which is the green color, in each row from the smallest to the largest. As you can see, the arrow of horizontal from left to the right. And then we need to create a key of the steam and leaf diagram so that people know how to interpret the diagram. As you can see, the right diagram, which is you can see the distribution curve, is the interpreting distribution of data from steam and leaf diagram that we construct before. So for the second day, as the weekday, we will apply the same thing like the first day, which is the first digit, that yellow color will become the steam, and the second number, that green color, will become the leaf. And then we build the interpreting distribution of data of steam and leaf diagram from the weekday. As you can see, the leaf will become the horizontal, will become the vertical magnitude in ascending order. So after that, after we build the interpreting distribution of data from day 1 and day 2, we will compare to observe that the distribution will more to the white side. Then, so from our studies of the spot speed, we can see the distribution shows the most data are clustered at the left. So the right tail is then further from the data center than the left tail. So that we can conclude, therefore, the distribution is skewed to the right or positively skewed.
For the next method of data presentation, we use box and whisker. There are two box and whisker produced in this project. Let me focus first on day 1, which is weekend. To produce box and whisker, first we need to arrange the data collected. Next, find the minimum, maximum Q2, Q1, Q3, upper inner fence and lower inner fence. For weekend, we found that the value for minimum is 55, maximum is 128, Q2 is 80.5, Q1 is 77, Q3 is 92.5, upper inner fence is 115.75 and lower inner fence is 53.75. After that, we need to create a box and whisker. It is found that there is an outlier, so modification needs to be done for maximum value. After the box and whisker have been modified, the new maximum value is 115 and there is no outliers. For the day 2, which is weekday, repeat the same step like day 1. Modification also need to be done on box and whisker because there is an outliers. After modification had been done, the new maximum value is 105 and there is no outliers.
Next is the analysis and result for descriptive statistics, which is mean and percentile. For the mean of weekend, we got 84.95 and for weekday is 78.45, and for median we got 80.5 for weekend and 77 for weekday, and mod is 80 for weekend and 78 for weekday. Next is the variance. We got 216.97 for the weekend and 195.64 for the weekday. For the standard deviations of weekend, we got 14.73 and for weekday we got 13.99, and for the percentiles on weekend, For P25, we got 79.5. For P50, we got 80.5. And for P75, we got 92.5. And for weekday, P25, we got 70.5. P50, we got 77. And for P75, we got 85.5.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badrul Amin Berosli. Number matric is DF200159. Today I would like to talk about the ZEC test. From the data that have been collected and calculated, the mean and the standard deviation. For the ZEC test, the step 1 is we need to state the null hypothesis HO and the alternative hypothesis HA. For our project, the HO that we assume is mu x is smaller and equal to mu y. For the HA, mu x is greater than mu y, so we assume that it's a one-tailed test. Step 2, we need to assume the level of significance. Our project is 0.05 or 5%. Next, we need to identify the test statistic. For the n and the m, we have same value is 40 because the sample size of both is 40. We calculate the z and we get the 2.02, and the standard deviation we get at 10.33. The next step is we need to formulate a decision rule. For the degree of freedom, TF, we get 78, and the critical value we get a 1.65. And lastly, we make a decision. Since the calculate Z is 2.02 is greater than critical Z 1.65 and does not fall in the rejection region, we reject the HO, thus we accept the HA, which says they are greater in the speed limit between day 1 and day 2.
Statistic F test for two variants. For the mean, day 1, we get 84.95. Day 2, we get 78.45. For the variance, day 1, we get 216.5. And day 2, we get 195.6. The null and alternative hypothesis, as you can see on the screen. This significant level is alpha equal to 0.10. The degree of freedom in the numerator V1 and V2 both equal to 39. Since this is a two-tailed test, the alpha is equal to 0.05. Next, from the critical F table, the critical table F value is 1.69. As you can see on the screen, the critical value of F table, V1 is equal to 40 and V2 is equal to 40. So we get the answer from the table is 1.69. And for the F calculated, variance day 1 divided by variance day 2, we get 1.106. Since the calculated F 1.106 is lower than the critical F 1.69 and fall in the rejection region, we accept HO and reject HA. We state that there is a difference in variation of the traffic speed for both day of weekend and week. Next, for the checking using Excel ANOVA table, the mean, variance F and critical F value is same.
So next we will go for the 5.0 discussion of data analysis for respondent data. So data survey on traffic speed at Jalan Keluang in front of RTD enforcement station Sri Gading for 2 days. That was obtained from the respondent through the Google form that was separated online, which is from the application of WhatsApp. Then the data for the day 1 was obtained weekend on Friday at evening, and the data for day 2 was obtained by weekday on Thursday, also on the same time, which is at evening. The reason data was taken on separate day because to evaluate the differences traffic speed on weekday and weekend. As usually, traffic will be heavy on evening, weekday as people will be rushing to get home from workplace. So as for the weekend, traffic will be less busy on the location as usually people will have rest day at home. The total number of respondents for both day is 80, which is 40 respondents on each day. So by doing our analysis through the Google form, as you can see for day 1 and on weekend day, the traffic speed data on weekend, the highest data that we will get is between 80 to 89 km per hour, which is 40% of respondent, and the mean is 16 of 40 respondent that vote for 80 to 89 km per hour. Then the lowest data on weekend traffic speed is in between 120 to 190 km per hour, which is one of the 40 respondents only that vote for that traffic speed. So by that, the percentage of respondent versus specific traffic speed data on weekend, as you can see, the detail of the range of speed study is 9 respondents state for 80 km per hour, and the lowest frequency state by the respondent is 1 respondent state as 128 km per hour for weekend specific speed data. Nextly, for day 2 on weekday, the highest data on weekday traffic speed in between 70 to 79 km per hour, which is the 45% of the respondent, which is 80 of 40 respondent. Based on the pie chart 2, the lowest data on the weekday traffic speed is in between 100 to 190 km per hour, which is one of the 40 respondent. Then the specific traffic speed data on weekday, the highest frequency of speed stated by the respondent is 4 respondents state 78 km per hour, and the lowest frequency stated by the respondent is 1 respondent state that 105 km per hour.
The stem and leaf diagram. From the data obtained by the traffic speed of the stem and leaf diagram was straight, as the key is right tail extend further from the data center than the left tail. Therefore, the distribution is skewed to the right or positively. Next, for the box and whisker weekend data, the minimum number is 55, the maximum number is 128. The upper inner fence is 115.95, the lower inner fence is 53.95, 53.75. So the data have outlier and the modification need to be done by determine max new. After determining max new, which is 115, the data become no outlier. For the box and whisker weekday data, which is day 2, the minimum number is 54, the maximum number is 120, the upper inner fence is 108, the lower inner fence is 48. So the data have outliers and modification need to be done by determine max new. After determine max new, which is 105, the data have become no outlier. For the descriptive statistic, mean and percentile, the mean, median, mode, variance, standard deviation for weekend and weekday, as you can see on the screen. The percentile for weekend data, for percentile 25 is 79.5, for percentile 50 is 80.5, for 75 percentile is 92.5. For the weekday data, the percentile for 25 is 70.5, for percentile 50 is 77, and for 75 percentile is 85.5. Next, for the significant testing, Z-test. From the data obtained, the weekend mean and weekday mean and standard deviation, as you can see on the screen. The null and alternative hypothesis also stated, as you can see on the screen. It is a one-tailed test. The significance level is alpha equal to 0.05. We assume that from the data calculated in formula, the Z is 2.02. The degree of freedom, DF, is equal to 78. The critical Z value is 1.65. Lastly, the conclusion. Since the data calculated Z 2.02 is greater than critical Z 1.65 does not fall in the rejection region, we do not reject HO. Thus, we accept HA, which say there is a greater in-speed limit km per hour between weekend and weekday. For the inferential statistic, F-test for two variant, the mean and variant as you can see on the screen, also the null and alternative hypothesis. The significant level is alpha equal to 0.10. Degree of freedom numerator V1 and V2 is equal to 39. Therefore, from the critical F table, the critical F table value is 1.69. Since the calculated F 1.106 is lower than critical F 1.69 and fall in the rejection region, we accept HO and reject HA, which state that there is a different in variation of the traffic speed for both day, weekend and weekday.
Lastly, for part conclusion. As a conclusion, based on a project that has been undertaken about study on traffic speed at the Jalan Keluang, shown that the calculation from the mean and standard deviation that have been calculated from the data that have been recorded from the Google form shown that speed at the weekend are very high from the weekdays. From the test, they are calculated from the mean, standard deviation. We conduct the Z-test and the T-test and we conclude that the null hypothesis HO are reject and accept the alternative hypothesis HA because HO are smaller than HA. So we conclude that speed at the Jalan Keluang in the weekend faster than the weekdays. Furthermore, the statistic subject can help us define statistics for our life and can make easier for our daily life. So that's all from us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.